Hi, this video is about copying memory blocks and searching in memory. Here at address 80 I have specified a block of values. Data is a label, and with db you specify a data byte, which can be separated by a comma. I've entered 32 bytes. So here at address 80 until 9F you have the values. I want to copy these values to the address B0. Unfortunately, the 8085 has no command to copy bytes like the Z80. We have to write a specific code. I specify the source address in register HL. Source is a data label. The destination is specified in DE, and destination is 00B0. And in BC I specify the number of bytes to copy. That's 32. You could enter here 32 or just specify a new label, data and here is data and minus data. This syntax is assembler code. It has nothing to do with machine code. So you see here B is loaded with 20. 20 hex is 32 decimal. Loading the accumulator with the first value from memory, which is specified in HL. Exchanging DE with HL and saving the accumulator to the destination. Exchanging back DE with HL. Incrementing our source address, incrementing our destination address, decrementing our counter. Unfortunately, the 16-bit decrement doesn't set the flags. For that purpose, we're moving B to A, doing an OR with C, and jump on non-zero to the loop here. So BC is our counter, DE is our destination address, B0, and HL is our source address. Value is loaded, exchange, DE will be exchanged with HL. He will swap the destination and source address, so we can write to the memory address. I will speed up a little bit. BC is 0, Zero flag is 1, that's why he stopped. You can also do it in the reverse order. So source address is data E minus 1, because data E is A0 minus 1 is 9F. The destination is CF, and counter stays the same. Here we have to decrement. Decrement, this is fine. Maybe we can also change the value and add 2 to it. It has added 2 to it. Okay, that worked fine. For the next example, we want to search for a specific byte in the memory. Okay, clean up the code here. Beginning from address 80, it's a destination, we don't need a destination. Counter is correct, and the value we are looking for is in the accumulator. I want to look for the value 15. So here we are comparing the accumulator with the memory. If you found it, we will jump to found. Otherwise we have to increment the memory, decrementing our counter, and here we will override our search value, so I will save it to register D, which is not used. Jump on non-zero loop before I have to put back the accumulator with a saved value. The move does not change any flags, so you can safely jump after that. Okay, and let me clear the accumulator here. So with the accumulator cleared, I will know that he has not found the string. Loaded, compare M. No, we don't need the memory flag here, the memory view. So rate fast. Nah, maybe. Oh, finished. He found the value 15 at address 9, 4. 9, 4 is 15. I will search now for the value 35, which is not specified. And he finished. Accumulator is cleared. So he did not jump to found, but he cleared it here. The Z80 has specific commands for copying and searching. You may stay tuned, otherwise see you in the next part. Bye bye. Here at address 80 I have specified a block of values. Data is the label, and with dB you specify a data byte which can be separated by comma. I've entered 32 bytes. You can find here the values at starting from address 80 until 9F, and I want to copy this value to B0. For the Z80 it's a 4-liner. There are only 4 lines of code. Loading the source address in register HL, that's a label data. Then loading the destination address 00B0, and loading the number of bytes you want to copy. That's BC, and I could enter 32 or use another label, name it data end. Yes, normal. The command is not completed. So data E is at value A0. So you can say here data end minus data. And he will load 20 hex, that's 32 decimal. This is not a machine code command, it's just an, how do you call it, from the editor, from the assembler here. He can do the calculation for you. Okay, and the last command, LDIR, and that's it. So the counter is loaded, destination is loaded, and the source is loaded. LDIR will take the first byte, put it to the destination, increment the source, increment the destination, and decrement the counter, and decrement it until it has reached 0. You can see he is always launching the same command. Oh, it has finished. So this means load, increment, repeat. You can remove the repeat. He will do it just once. LDI and the halt. He has just copied 1 byte. So you could have your own code here, and finally you would do a jump on parity even to the loop. LDI, parity is even. As long BC is not 0, parity will be even. BC here, parity is even. BC is 0, parity even is 0, so it means odd, he stopped the program. You can do it also in reverse mode. Means we are copying from 9F down to 80 to CF. So the source is data and -1. Destination is CF. The number of bytes to copy is the same. And here we are doing not increment, but a decrement. Memory. And it's doing it. PC is counting down. When it's 0, parity flag will be cleared, and he stops the program. Program stopped. You can do it also with a repeat. Just add a repeat and uncomment the jump. Is repeating this command until PC is 0. The next example is a search example. We want to search for a specific value in a memory block. So, starting at label data, destination is not needed. The length of the block, and the value we are looking for is in the accumulator. We are looking for value 15. And the command here is compare, increment, repeat. That's all. So he has stopped because he has found it. 0 flag is 1. And he tells us it's at address 95. 95, that's the next one. He has already incremented it. So we have to decrement HL at the end. And now it's 94, which is correct. Okay, what will happen if he doesn't find the value? Zero flag is 0 and parity flag is 0, so he hasn't found the value. To make a difference, you could say here if the 0 flag is set, so he has found the value, jump to found. That's a found. Otherwise, clear the accumulator, which means not found. He hasn't found the value, so he cleared the accumulator. Yes, not cleared the accumulator, so he has found the value at address 94. You can do it without a repeat, but then you have to add a jump. So, accumulator is not cleared, has found the value at address 94. Now, with the wrong value, he will take longer because he has to execute more commands than with the repeat. So accumulator is cleared, he hasn't found the value, which is correct. Last but not least, we have also the decrement function and -1. And here it's not increment but decrement. And here we have to increment. You won't find the value. Now it's decrementing. Hasn't found the value. Found the value at address 94. The same works also with a repeat. And then you don't need the jump here. Has found the address and is much faster. Specifying the wrong value. Hasn't found the value. Thank you for watching and see you in the next part. Bye bye.